Hi everyone, this video is going to be going over example problems for latent heat. Remember, latent heat, that formula we are going to use for phase changes, meaning from solid to liquid or gas to liquid, or any of those phase changes. That's when we're going to use the latent heat formula, which is Q equals M delta H. So Q is going to be energy, and again, it could be in joules or calories. M is mass in the unit of grams. Delta H is going to be your enthalpy, so your heat of vaporization or your heat of fusion. Okay, remember, heat of vaporization is used for the phase changes between a gas and a liquid, and a heat of fusion is going to be used for the phase changes between a solid and a liquid. Okay, so depending on what your problem is giving you or asking you, that's how you know which delta H you're going to use. So our first problem says how much heat is required to melt 46.5 grams of aluminum. The latent heat of fusion of aluminum is 95 calories per gram. So you'll be given the heat of fusion. In this particular problem, we are looking at aluminum. So notice that the question says melting. Okay, so melting means that we are going to be using delta H of fusion because fusion is between solids and liquids or liquids and solids. We're looking at melting, so we know that our delta H is going to be a positive value. If we're going from a solid to a liquid, the molecules are getting faster, and so it's an endothermic reaction. It's absorbing energy. Okay, so I'm going to write my formula, which is Q equals M delta H, and we established that we are going to use fusion. Okay, I'm going to list my variables. Q is heat. The question says how much heat, so that's what I'm solving for. M is mass. We have 46.5 grams. And then delta H of fusion is 95 calories per gram. Okay, just going to plug some numbers in. So we are solving for Q, so I don't have to rearrange my formula. So Q is equal to M is mass of 46.5 grams times delta H fusion, which is 95 calories per gram. I'm going to plug this into my formula, 46.5 times 95. And that gives me 4,417.5. This is going to be in the unit of calories. And as far as sig figs go, I have 2 up here, so my answer will be 4,400 calories. So what this means is that's how much heat is required to melt 46.5 grams. Here's example number 2. It says how much heat is released when 235 grams of water freezes. Okay, so we are looking at a phase change because it says freezes, so I know that I'm going to use Q equals M delta H. Okay, now remember, freezing is going from a liquid to a solid, so I am going to use delta H of fusion. Now there are 2 clues that tell you that your Q value is going to be negative. One is that it says how much heat is released. Okay, so Q is going to be negative because it's an exothermic reaction. And the second clue is that it's saying that water is freezing. So if I look at my little cheat sheet here, delta H fusion is negative when we're freezing because we're going from a liquid to a solid, and so our molecules are getting slower, so it has to get rid of some of that energy. So I'm going to list my variables, Q, M, delta H, fusion. Q is how much heat, so we are solving for that. M is 235 grams, and because we're looking at water, I'm actually going to use this value here. Okay, so this is the delta H fusion for water, which is 334 joules per gram. And like I said earlier, we're making this negative because we are going through an exothermic phase change. Okay, so again, I could just plug these numbers into my formula. So M is 235 grams. Delta H is negative 334 joules per gram. So my Q value is 235 times negative 334. That gives me negative 78,490. And this is actually going to be in the unit of joules. And if I'm looking at sig figs, I need to have 3 sig figs because both of those have 3. So this will be negative 78,500 joules.